In this video, I will show a detailed introduction into the R programming language. In the video, I will show you different topics, and in the first section of this video, I will show you how to manipulate and prepare your data sets. Then in the second section, I will show you how to create graphics in the R programming language. And this section will contain two subsections. So in the first part, I will show you how to use the basic installation of the R programming language to create graphics in R. And in the second subsection, I will show you how to create more advanced graphics using the ggplot2 add-on package. Then in the next section, I will show you how to analyze your data. So first I will talk about basic metrics such as the mean, the median, maximum and minimum values. And then I will also show you how to estimate linear regression models based on your data. And then last but not least, I will show you another section in which I will talk about more advanced topics such as for loops, if-else statements, and user-defined functions. So without too much talk, let's dive into the R code. So in the first section of this video, I will show you how to manipulate and prepare your data sets using the R programming language. So before we jump into the data manipulation, we first need to decide if we want to import external data into R or if we want to create our own data within R. And in this tutorial, I will show you different ways on how to create your own data. So this is what we will do in the first step of this tutorial. So in line 6 of the code, I'm first showing you how to create a one-dimensional vector object. And we can do that using the C function, as you can see in line 6. And within the C function, you need to specify the values that your vector object should contain. So if you run line 6 of the code, you can see at the top right of RStudio that a new vector object is appearing in the workspace. And this vector object is called vec1. And we can print this vector object to the bottom in the RStudio console by running line 7 of the code. And then you can see that we have created a vector object which contains 6 values, and these values are numeric. So in this first step, I have shown you how to create a one-dimensional vector object. However, in most cases, you will deal with data frames that contain different rows and columns. And in the next step, I want to show you how to create a data frame in the R programming language. So we can do that, as you can see in lines 9 to 11 of the code. And in these lines of code, I'm specifying the data frame function. And within this function, I'm specifying that I want to create a data frame with 3 columns. These columns should be called x1, x2, and x3. And to each of these columns, I'm assigning a vector which is containing different values. So the first column should contain these values. The second column should contain these values. You might already notice that the second column will contain letters instead of numbers. And the third column will contain a sequence from 11 to 16. And we can specify that using this double point operator. And then if you want to store the output of the data frame function in a new data object, you need to use the assignment arrow, as you can see in line 9. This is the same principle that we have already used in line 6 of the code. And then we are creating a new data set, which is called data1. So if you run lines 9 to 11 of the code, you can see at the top right of RStudio that a new data object is appearing, which is called data1. And we can print this data object to the bottom in the RStudio console by running line 12 of the code. And then you can see at the bottom in the RStudio console that we have created a new data set containing 6 rows and 3 columns, which are called x1, x2, and x3. And as you can see, each of these columns contains different values that correspond to the values that we have specified in the creation process of the data frame. So in this second example, I have explained how to create a two-dimensional data frame. However, another very important data type in the R programming language are lists, and this is what I want to show you in the next example in lines 14 to 17 of the code. So if we want to create a list object, we have to apply the list function, as you can see in line 14. And then within the list function, we need to specify the elements that our list should contain. So in this case, I'm specifying 3 list elements. And the first list element is a range from 1 to 5. The second list element should contain the values in the vector that we have created in the beginning. So this vector object is called vec1, and for that reason we simply need to specify the name of this data object within the list function. And the same is true for the data frame that we have created before, the data frame data1. So we are also specifying that this data frame should be contained as third list element in our list. So if you run lines 14 to 16 of the code, you can see at the top right of RStudio that a new list is appearing, which is called list1. And we can print this list to the bottom in the RStudio console by running line 17 of the code. And then you can see by opening the RStudio console that our list contains 3 elements. This is indicated by the value 1, the value 2, and the value 3 in double square brackets. So each of these numbers corresponds to 1 list element. And as you can see, our first list element contains a sequence from 1 to 5. The second list element contains our vector object vector1. And the third list element contains the data frame data1. So as you have seen in these first steps, we can create different types of data objects in the R programming language. So in this specific example, we have created a vector object, a data frame object, and a list object. And depending on your specific needs, you might want to use one of these different data types in R. So now that you have learned something about the different data types in the R programming language, I also want to show you how to check the classes of your data values, because this is very important in case you want to perform some analysis with your data. We can check the classes of our data objects using the class function, as you can see in line 19 of the code. So within the class function, you need to specify the data values that you want to check. So in this case, I want to check the values in our vector object vec1 that we have created in the beginning of the tutorial. So if you run line 19 of the code, you can see at the bottom in the RStudio console that the word numeric is returned. And the numeric class is a very important class in the R programming language, because this class is used for numbers. In the following lines of codes, I want to show you some different classes that are used in the R programming language. And for this, I'm going to create some further data objects. So in line 21 of the code, I'm creating another vector object using the C function. And within the C function, I'm specifying different letters. You can also see a difference because of the quotes, because if we are specifying non-numeric values, we have to wrap quotes around these values. So if you run line 21 of the code, you can see that another vector object is appearing at the top right. And we can print this vector object by running line 22 of the code. And then you can see at the bottom in the RStudio console that our vector contains 4 letters, or more precisely the letters A, B, A, and C. Now if we want to check the class of this vector object, we again can apply the class function as we already did in the previous example, as you can see in line 24 of the code. And in this case, I'm specifying the name of our second vector object, vec2. So if you run line 24 of the code, you can see that the second vector that we have created has the character class. And the character class is always used when you are dealing with text elements. The third class I want to show you is the factor class, and we can create a factor vector using the code that you can see in line 26. So if you run line 26 of the code, you can see at the top right that another vector object is appearing, which is called vec3. And we can print this vector to the bottom in the RStudio console by running line 27 of the code. And now you can see that the output looks a little bit different, because this time we have again specified characters within quotes. However, you can also see that this time the output shows certain levels in our vector object. And the levels correspond to each possible value that the elements in our vector can have. So in this case, we have 3 groups in our data: the group number 1, the group number 2, and the group number 3. So based on this output, we can already see that our vector object has a vector class. However, we can also check this class using the class function. Once again, as you can see in line 29, so if you run this line of code, you can see that now the elements in our vector have the vector class. And the vector class is usually used when we are dealing with categorical data. So to summarize, we have seen 3 different classes in this section. The first class was the numeric class, which is used for numbers. The second class was the character class, which is used for text elements. And the third class is the vector class, which is used for categorical data. So sometimes you might want to change the class of a data object, and this is what I want to show you in the next step in line 31. So in this case, I want to convert our vector, the vector number 3, to the character class. And to do this, we can use the sCharacter function, as you can see in this line of code. And within the sCharacter function, you simply need to specify the name of the data object that you want to convert. So in this case, I want to convert the data object vec3, and I want to create a new data object where I'm storing the output of this, and this output should be called vec4. So if you run line 31 of the code, you can see that another vector is appearing at the top right, which is called vec4. And if we print this vector to the bottom in the RStudio console, you can see that the values in this vector are the same as in our input vector. So again, we have the groups number 1, number 2, and number 3. However, this time our output does not show any levels. And we can also confirm that output by running line 34 of the code. And then you can see that our new vector object, vec4, has the character class. So this is all I wanted to tell you about different data types and data classes in the R programming language. So let's move on to the next part of the tutorial, where I want to show you how to manipulate data frames and how to add and remove columns and rows from your data frames. So this next part is starting in line 36 of the code. And as you can see in this line of the code, I'm creating a new data frame, which is a duplicate of our first data frame, data1, that we have created in the beginning of this tutorial. And I'm doing that because I want to keep an original version of our first data frame. So if we want to create a duplicate of a data object, we simply need to specify the name of this data object. Then we need to use the assignment arrow, and then we need to specify the new name of the duplicate that we want to create. So if you run line 36 of the code, you can see at the top right that a new data frame object is appearing, which is called data2. And this data frame contains at this point of the tutorial exactly the same values as our first data frame. However, in the next step in line 37 of the code, I'm adding a new row to this data frame. And we can do that using the dollar operator, as you can see in line 37. And after the dollar operator, we need to specify the name of our new column. So in this case, our new column should be called x4. And then we are assigning to this the values that our new column should contain. And in this case, I want to add the vector object that I have created in the beginning of this tutorial as a new column to our data frame. So after running line 37 of the code, our data frame is updated, and we can see that by printing this updated data frame to the RStudio console by running line 38 of the code. So after running this line of code, you can see that we have created a new data set which contains the 3 columns x1, x2, and x3 that were already contained in our input data frame. However, this data frame also contains a 4th column, which is called x4, and this column contains the values of our vector object vector1. So in the previous lines of code, I have explained how to add a new column to a data frame. However, of course, it's also possible to remove certain columns from a data frame, and this is what I want to show you in the next line of code in line 40. And in this line of code, I'm using the data2 object that I have created before, which contains the 4 columns x1 to x4. And in this line of code, I want to remove the second column x2. And we can do that using square brackets. Then we need to specify a comma to tell R that we want to manipulate the columns of our data frame. And then after the column, we need to apply the colnames function. And then we are specifying that we want to keep only those columns that have a different colname than x2. So in other words, we want to delete the column x2. So if you run line 40 of the code, another data set is created, which is called data3. And we can print this data set to the RStudio console by running line 41. And then you can see that our new data frame contains the columns x1, x3, and x4. However, the column x2 has been removed. So let's assume that in this data frame we also want to change the column names. Then we can do that, as you can see, in lines 43 to 44. So in line 43, I'm again creating a duplicate of our input data, and I'm using the input data data3, and I'm creating a new data frame object which is called data4. So if you run line 43 of the code, another data frame is appearing at the top right, which is called data4. And then in line 44 of the code, I'm changing the column names of this data frame. And for this, we can once again use the colnames function. And in this case, we are applying this function to our data set. And then we are assigning to these colnames a vector of new column names. So in this case, we want to use the new column names col A, col B, and col C. So after running line 44 of the code, our data frame column names are updated. And we can see that by printing the data frame to the RStudio console by running line 45 of the code. And then you can see that our new data frame data4 contains the same values as our input data frame. However, you can also see that the column names have been changed to col A, col B, and col C. So in the previous lines of code, I have explained how to change the columns of a data frame. However, it's also possible to manipulate the rows of a data frame. And in the next line of code, I want to show you how to add a new row to a data frame. And we can do that using the rbind function, as you can see in line 47 of the code. And within the rbind function, we need to specify the name of our input data set. So once again, I'm using the data set data3. And then we need to specify the values that we want to add as a new row. Make sure that the number of values that you are assigning as a new row is the same number as the number of columns in our data set. So in this case, we need to specify 3 new values. And in our specific example, we are using a range from 101 to 103. And then we are storing the output of this in a new data frame, which is called data5. So if you run line 47 of the code, you can see that another data frame is appearing at the top right, and we can print this data frame with line 48 of the code. So if you run this line of code, you can see that our data frame contains a new row which contains the values 101, 102, and 103. In the next line of code, I want to show you how to remove certain rows from a data frame. And in this case, I'm using a logical condition. And this logical condition says that I want to keep only those rows where the column x1 is larger than the value 3. And then I'm storing the output of this in a new data frame, which is called data6. So if you run line 50 of the code, you can see that another data frame is appearing, and we can print this data frame to the bottom by running line 51. And then you can see that our new data frame contains the same columns as our input data frame data5. However, you can also see that some of the rows have been removed from our dataset. Actually, you can see a little typo here, so this should be called data5. However, the output should be the same if we run this line of code. So if we run this once again, you can see that the output is the same. So in the previous examples, I have explained how to add new rows and columns to a data frame simply based on the ordering of the rows and columns in this data frame. However, it's also possible to merge two data frames based on an ID column. And this is what I want to show you in the next example, starting in line 53 of the code. So in these lines of code, I'm first creating two new data sets that we will use in the example afterwards. So in lines 53 to 55 of the code, I'm creating our first data frame for this merging example. And if we run these lines of code, you can see another data set, which is called data7, appearing at the top right. And we can print this data set to the bottom in the RStudio console by running line 56. And then you can see that our new data frame contains an ID column and two other columns, which are called x1 and x2. And these columns contain character letters. Then we need to create another data frame that we can merge with our first data frame. And this data frame will be called data8 and can be created with lines 58 to 61. So if you run these lines of code, another data frame is appearing at the top right, which is called data8. And if we print this data frame to the bottom in the RStudio console, you can see that this data frame also contains an ID column. You can already see that some of the IDs are overlapping with our previous data frame, but not all of them. And you can also see that the column names in this data frame are different compared to the first data frame. So if we want to merge these two data frames based on the ID column, then we can use the merge function, as you can see in line 64 of the code. And within the merge function, we need to specify our first data frame as X argument, our second data frame as Y argument. Then we need to specify the column name of the column that we want to use to identify the observations in our data sets. And in this case, I'm using a full outer join. So in other words, I'm keeping all data rows that are stored in our two input data sets. So if you run lines 64 to 67 of the code, you can see that another data frame object is appearing at the top right, which is called data9. And we can print this data set to the bottom in the RStudio console by running line 68. And then you can see that we have created another data frame which contains the ID column that both data frames have contained as well. And it contains the columns of the first data frame and the columns of the second data frame. However, you can also see that the columns have not just been combined with each other, they have been combined based on the ID column. And for those rows where a value in the ID column was only existing in one of the data frames, the merge function has inserted an A values for the data frame in which this row was not contained. So for instance, the ID number 101 was only contained in the first data frame, and for that reason the values in the columns of the second data frame have been set to an A. However, you can also see that some of the ID values have been overlapping because the ID numbers 104, 105 and 106 have been contained in both data frames, and for that reason those rows contain values in all of the columns. So in the previous lines of code, I have shown you how to add or remove data sets together. However, another thing that I want to show you is how to replace certain values in your data. And in the next lines of code, I will show you how to replace certain values in a vector object. So in line 70 of the code, I'm first duplicating our vector object vector1 that we have created in the beginning. So if you run this line of code, you can see that another vector object is appearing at the top right, which is called vector5. And this vector object contains the same values as the vector object vector1. So as you can see at the top right, the values 1, 1, 5, 3, 1, 5. Now in this example, I want to show you how to replace the value 1 by the value 99. And we can do that, as you can see in line 71. So in this line of code, I'm using a logical condition within square brackets. And in this logical condition, I'm specifying that I want to subset all values where the vector 5 is equal to 1. And then I want to assign to this subset the value 99. So if you run line 71 of the code, our data object is updated, as you can see by printing this vector to the bottom in the RStudio console by running line 72. And then you can see that all the values 1 in our input vector have been replaced by the value 99. Similar to that, we can also replace values in a data frame object, and this is what I want to show you in the next example, starting in line 74 of the code. So once again, I'm duplicating our first input dataset data1, and I'm storing the dataset in a duplicate called data10. And then in this case, I want to replace the character y in the column x2 by the new character string new. So if you run line 75 of the code, our dataset is updated, and you can see that by printing line 76 to the bottom in the RStudio console. And then you can see that our new data frame contains the same values as the data frame data1. However, the value y has been replaced in the column x2 by the new character string new. So this is basically what I wanted to show you about data manipulation in R. However, at this point we have created many different data sets, and for that reason I also want to show you how to export and import such data sets from and into R. And in the next lines of code, I will show you how to write the dataset data10 to a CSV file in a folder on my computer. So for this, we first need to check the working directory that is currently used in this R programming session. And we can do that by using the getWD function, as you can see in line 78 of the code. So if you run this line of code, you can see that our current working directory is the documents folder on my computer. However, let's assume that in this example, I want to store the output in another folder on my desktop, which is called my directory. So as you can see at this point of the tutorial, this folder is empty. And if we want to store a data frame in this folder as a CSV file, we first need to use the setWD function to set our current working directory to this folder. So if you run line 80 of the code, our working directory is updated, and we can see that by running the getWD function once again, as you can see in line 82. So after running this line of code, you can see that now the path of our current working directory is leading to this folder on my desktop. Then in the next step, I can use the write.csv function to create a CSV file. And within this function, we need to specify the name of the data frame that we want to export to our folder. Then we need to specify the name that this file should have. So in this case, we are calling the file data10.csv. And in this case, I also specify that I want to avoid printing row names to this CSV file. So if you run lines 84 to 86 of the code, our data frame data10 is exported, and you can see that by opening this folder once again. And as you can see, now this file has been stored in this directory on our computer. So if we want, we could also import such CSV files into R, and we can do that using the read.csv file, as you can see in line 88. And within the read.csv file, you only need to specify the name of the CSV file. So for illustration, I'm just importing this data set once again into R. And we also need to store the output of the read.csv file in a new data object that we are calling data11. So if you run line 88 of the code, you can see that another data set is appearing at the top right, which is called data11. And we can print this data set to the RStudio console by running line 89. And then you can see that we have imported this data set that we have exported before as a CSV file back into R. In the second section of this tutorial, I want to show you how to create graphics using the R programming language. However, before we can start to draw our data, we first need to import a new data set into R, because the data frames that we have created in the previous section are relatively simple and I want to visualize more complex data. So to do that, we can use the code that you can see in line 95. And in this line of code, I'm applying the data function to the iris dataset. So the iris dataset is a dataset that is already loaded with the basic installation of the R programming language. However, we can import this dataset using the data function, as you can see in line 95. And after running this line of code, you can see at the top right of RStudio that a new dataset called iris is appearing. And we can have a look at the first 6 rows of this dataset by running line 96 of the code. So after running this line of code, you can see at the bottom the first 6 rows of our data frame. And as you can see, this data frame contains 4 columns with information about the sepal length, the sepal width, the petal length, and the petal width. And it also contains a column which is identifying the species of the different flowers. So in the first part of this section, I will show you how to draw our data in different types of plots using the basic installation of the R programming language. So in the first plot that I will create, I'm creating a scatter plot. And on the x-axis of this plot, I want to show the sepal length. And on the y-axis of this plot, I want to show the sepal width. And for this, we need to specify within the plot function these 2 columns. And in addition to that, I'm also specifying that the colors of our data points should correspond to the species in our data. So if you run lines 98 to 100 of the code, you can see at the bottom right of RStudio that a new plot is created. And as you can see, this plot is a scatter plot, which shows the data points in our columns sepal length and sepal width and the relationship between these 2 columns. You can also see the different colors for the different species in our data. So in the next step, I want to show you how to draw a density plot, and we can do that using the plot function once again. Then we also need to use the density function, and then we need to specify which column we want to draw in this density plot. So if you run line 102 of the code, you can see that a density is created for the column sepal length. So on the x-axis of this plot, the values of this column are shown, and on the y-axis, you can see the density. Another way to visualize your data in R is by using the histogram function, as you can see in line 104. And as in the density function, we simply need to specify the column that we want to show in a histogram. So if you run line 104 of the code, you can see that a histogram is created of our data frame column sepal length. And last but not least, I want to show you how to draw a box plot of each of the species in the column sepal length. And for this, we can use the box plot function, as you can see in line 106 of the code. And within this function, we need to specify the column that we want to draw in the box plots. Then we need to specify a tilde, and then we need to specify the grouping column. So in this case, the groups of our data are defined based on the species column. So if you run line 106 of the code, you can see that 3 box plots are shown side by side in a single graphic. And on the x-axis of this box plot graphic, you can see the 3 different species in our data. So in these first examples of the second section, I have shown you how to use the functions of the basic installation of the R programming language. And these functions provide many different alternatives on how to manipulate your plots. However, I want to move on to an add-on package that is provided by the R programming language, which is called ggplot2, because this package is very popular in the R programming community because it creates very beautiful plots. And for that reason, I want to focus mainly on the ggplot2 package instead of base R. So if we want to use the functions of the ggplot2 package, we first need to install and load the ggplot2 package, as you can see in lines 108 and 109. And this is, by the way, also a good example on how easy it is to install and load new add-on packages to R. Because first, you only need to apply the install packages function to the name of the package that you want to install. This needs to be done only once. So for that reason, I'm not running this line of code because I have installed this package already. And then in line 109 of the code, I'm applying the library function to load the functions of this package into my current R session. And this needs to be done once per session. So in this case, I have not loaded the functions yet. And for that reason, I'm going to run this line of code to load the ggplot2 functions into my current R session. So after running this line of code, we are able to use the functions of the ggplot2 package, such as ggplot, as you can see in line 111 of the code. And in the first ggplot2 plot that I'm creating, I want to create a scatter plot similar to the scatter plot that we have created with base R. So within the ggplot function, we need to specify the name of our dataset. So in this case, our dataset is called iris. Then we need to specify the aesthetics of our dataset. And within the aesthetics, we need to specify the two column names that we want to show on the X and Y axis. And I'm also specifying that the colors should be based on the species column, similar to the scatter plot that we have created with base R. And then we need to add to this the geonPoint function, because the geonPoint function specifies that we want to draw a scatter plot. So if you run lines 111 to 115 of the code, you can see at the bottom right of RStudio that a new scatter plot is created. And this scatter plot is showing the columns sepal length and sepal width. And you can also see that the colors of the dots in this scatter plot are based on the species column. And in addition, you can also see that the ggplot2 package automatically draws a legend on the right side of the plot, which is showing the colors and the different species groups in our data. So as you have seen in this first ggplot2 example, we have used only a few lines of code and we have already created a relatively beautiful plot in R. So in the following examples, I want to show you different applications of the ggplot2 package. So in the next step, I want to show you how to create a density plot based on our data using the ggplot2 package. And for this, we once again need to apply the ggplot function, as you can see in line 117. Then we need to specify the data and the column that we want to use. And in this case, we need to apply the geonDensity function because we want to draw a density plot. So if you run lines 117 to 119 of the code, you can see at the bottom right of RStudio that a relatively simple density plot of our column sepal length is appearing. However, we can also modify this code, as you can see in lines 121 to 124. So the only difference here is that I'm specifying the color to be equal to our species column. So if you run these lines of code, you can see that our plot is updated. And this time we have drawn each group in our data, each species in our data, in a different density. So in this plot, you can see 3 different densities based on the species groups in our data. So for instance, now you can see that the setosa density has a much lower sepal length. So the sepal length of these flowers is usually smaller. We can further modify this plot, as you can see in the following examples. So in the next example, in lines 126 to 130 of the code, I'm adding a filling color to this code. So if you run these lines of code, you can see that our plot is updated once again, because this time we have filled the densities based on their groups. However, now you can also see that the densities are overlapping, and for that reason we could also specify an alpha value, as you can see in the next example, within the geonDensity function to make the densities in our plot transparent. So let's run these lines of code, and then you can see that our plot is updated once again, and now our densities are shown with a certain level of opacity, and for that reason you can see the entire densities once again. So now I have shown you different alternatives on how to visualize your data in a density plot. However, the ggplot2 package provides many other types of plots, and in the next lines of code I want to show you how to create a histogram using the ggplot2 package. And once again, for this we need to apply the ggplot function, we need to specify our data set and the column that we want to draw. And in order to draw a histogram, we need to add the geom histogram function. So if you run these lines of code, you can see that another plot is created at the bottom right. And this graphic is showing a histogram of the entire column sepal length. In the next lines of code, I'm using the geom boxplot function in combination with the ggplot function to create a boxplot. And for this, because I want to draw a separate boxplot for each of the species in our data, I'm specifying the x-axis to be equal to the species column and the y-axis to be equal to the sepal length. So if you run these lines of code, you can see that another graphic is created, and this graphic shows our 3 groups in 3 different box plots side by side. Now we can also change the filling colors of these boxes using the fill argument, as you can see in lines 147 to 151. So the only difference compared to the previous code is that now I'm specifying the fill argument to be equal to species. So if you run these lines of code, you can see that our plot is updated once again. And as you can see, this time our plot is shown with different colors. And you can also see a colored legend on the right side of the plot. So one very popular type of plot that I have not shown yet are bar plots. And in the next examples, I want to show you how to draw bar plots using the ggplot2 package. And for this, we first need to manipulate our data a little bit. And for this, I'm first duplicating our iris data set, as you can see in line 153. You might already know this from the first section of this tutorial, from the data manipulation section. So at this point, we are simply duplicating the iris data set. Then in the next step, I'm also creating a subgroup column using the code in line 154. So I'm creating a new column which is called sub, and I'm assigning to this a sequence of the letters A, B, and C. So if you run this line of code, our new data set is updated once again. And then in the next step, I'm using the aggregate function to calculate the mean for each subgroup in our data. So within the aggregate function, we need to specify the formula based on which we want to define the subgroups. So I want to create subgroups for the column sepal length based on the 2 columns species and sub. The name of the data frame is iris groups. This is the data set that I have created before, and I want to calculate the mean within each of these groups. So if you run lines 155 to 157 of the code, our data set is updated once again, and we can print our final manipulated data set by running line 158. So after running this line of code, you can see at the bottom in the RStudio console that we have created a data frame containing only 9 rows. And you can also see that this data frame contains 3 columns. The first column specifies our species. The second column is our subgroup indicator that we have manually created before, which is showing the letters A, B, and C. And the third column is showing the mean value for each subgroup for the column sepal length. So if we now want to draw a bar plot based on these data, then we can apply the code that you can see in lines 160 to 163. So in these lines of code, I'm once again using the ggplot function. I'm specifying our new data set iris groups. On the x-axis, I'm specifying the species column, and on the y-axis, I'm specifying the sepal length column. And then I'm adding to this the geom bar function to tell the ggplot2 package that I want to create a bar plot. And within this function, I'm specifying stud identity. This is because we have formatted our data as I have shown below. So if you run these lines of code, you can see at the bottom right of RStudio that a new bar plot is appearing, which is showing the mean value within each species. However, you can also see that we have not shown any colors in our plot, and you can also see that the subgroup indicator that we have created before is not taken into account into this plot. So if we want to change this, we can also use the fill argument, as you can see in line 168. So these lines of code are exactly the same as in the previous example. However, this time I'm also specifying the fill argument to be equal to our subgroup indicator. So if you run these lines of code, you can see at the bottom right of RStudio that our plot is updated. And this time we have created a stacked bar plot, which is still showing our 3 species at the x-axis and the mean values for each of these species. However, you can also see that each of the bars is separated by our subgroup indicator. So the values of the subgroup A are shown in red, the subgroup B is shown in green, and the subgroup C is shown in blue. So in this example, I have shown how to create a stacked bar plot. However, another alternative is shown in the next example in lines 171 to 176. And in this case, I'm again using basically the same syntax as in the previous example. However, this time I'm also specifying the position argument within the geonBar function to be equal to dodge. So if you run these lines of code, you can see at the bottom right that our plot is updated once again, and now we are showing our data in a grouped bar plot. So in this section I have explained how to create graphics using the basic installation of the R programming language and the ggplot2 add-on package. However, there's much more we can do with our data, so let's move on to the next section. In the previous section, I have explained how to analyze your data based on different types of graphics. However, it's also possible to analyze your data based on different descriptive metrics. And this is what I want to show you in this section of the tutorial, starting in line 179. So in the first part of this section, I will explain how to calculate basic descriptive statistics, such as the mean, the median, the minimum and the maximum, and so on. So if we want to calculate the mean of a data object, we can apply the mean function to this data object, as you can see in line 182 of the code. And in this case, I want to calculate the mean of our vector object vec1 that we have created in the first section of this tutorial. So if you run line 182 of the code, you can see at the bottom in the RStudio console that the mean of our vector object vector1 is 2.667. So as you have seen, it's relatively simple to calculate the mean of a data object, and similar to that we can also calculate other metrics such as the median in line 184. So the median of our data object is the value 2, the minimum is 1, the maximum is 5, the sum of all values in our vector object is equal to 16. And then in lines 192 and 194, we can also calculate the variance and the standard deviation of our data object. So the variance of our vector object is 3.87 and the standard deviation is equal to 1.966. So as you have seen, the R programming language provides many very simple functions to calculate descriptive statistics of your data. However, a very useful function is the summary function that you can see in line 196, because if you apply this function to a data object, several different metrics are printed to the RStudio console. So in this case, since we have applied the summary function to our vector object, the minimum, the first quartile, the median, the mean, the third quartile and the maximum values are returned to the RStudio console. We can also check the frequencies of the values in our data object by creating a frequency table, and we can do that as you can see in line 198. So in this line of code I'm applying the table function to our data object. So after running this line of code, you can see at the bottom that our output shows the name of our data object vec1, And then in the first line of this output, it shows the different values in our data object. So our vector object contains the values 1, 3, and 5. And in the second row of this frequency table, it shows how often each of these values occurs. So the value 1 occurs 3 times, the value 3 occurs only once, and the value 5 is contained twice in our vector object. We can also apply the table function to create a contingency table based on 2 columns of a data frame. So for this example, I'm using the first data frame that I have created in section number 1, which is called data 1. And I'm subsetting this data frame using square brackets and using a vector of the column names that I want to use. And then I'm applying to this data frame subset the table function. So if you run line 200 of the code, you can see at the bottom that a contingency table is returned. And this table shows on the left side the column x1 and on the upper side the column x2. And then it shows all combinations of these values in these 2 columns. So for instance, the combination of the value 2 in the column x1 and the value x in the column x2 is appearing 0 times, so it's not appearing at all in our data. However, for instance, the value 3 and the value x is appearing twice. So as you have seen in the previous lines of code, it's relatively easy to get certain metrics of your data, such as descriptive statistics and such as counts based on the values in your data objects. However, the R programming language also provides many functions to estimate regression models. And in the next 2 examples, I want to show you how to estimate different linear regression models. And for this, we can use the LM function, as you can see in line 202 of the code. And within the LM function, we first need to specify the formula of our regression. So in this case, I want to use the variable sepal width as dependent variable and the variable sepal length as predictor variable. Then within this function, we also need to specify the name of our data set. So once again, we are using the iris data set that we have loaded in the previous section in the graphical section of this tutorial. And then we are storing the output of this in a new data object, which is called mod1. So if you run these 2 lines of code, you can see at the top right of RStudio that a new object is appearing, which is called mod1. And this is actually a model object that we can insert into the summary function. So the summary function can also be applied to models. And if we run this line of code, you can see that a relatively detailed output is returned. So this output shows you different estimates for your model. So very important are, of course, the regression coefficients. So in this case, you can see the intercept of our model, and this intercept is significant. However, you can also see that the sepal length as predictor variable for the variable sepal width is not significant. And if you remember the plots that we have created before, this is kind of surprising because it seemed like there is a relationship between these 2 variables. And for that reason, I want to show you once again how to create another graphic using the ggplot2 package. So in this case, we are creating a scatter plot using the geom_point function, exactly the same way as we already did in the previous section. However, this time we are also adding the geom_smooth function to this plot. And within this function, we are specifying that we are estimating a linear model. So if you run these lines of code, you can see at the bottom right that another plot is created. This plot is showing a scatter plot of the 2 variables sepal length and sepal width. And in the middle of this plot, you can also see a regression line with standard errors around the line. And as you can see, this line is relatively flat, so it makes sense that the regression coefficient that we have estimated in our model is not significant. However, in this first model, we have only used a very simple model because we have only used the variable sepal length as predictor. And for that reason, I want to estimate another linear regression model based on multiple predictor variables. So in this case, I'm also adding the species variable as a second predictor to our model. So if you run these lines of code, you can see that another model object is appearing at the top right, which is called mod2. And in this case, our formula has been improved. And you can also see that by applying the summary function once again to our new model object. So after running this line of code, you can see that another output is created. And as you can see, in addition to the intercept and the variable sepal length, we also can see two other predictors, and these two predictors show the species versicolor and the species virginica in reference to the species setosa. And as you can see now in this model, all our predictors are significant. So even the predictor variable sepal length, which was not significant in the previous example, is now significant as well. And the two species predictors are also significant. And we can also visualize that once again using the ggplot2 package, as you can see in lines 218 to 223. And the difference compared to the previous plot is that this time I'm also specifying the color argument to be equal to the species. So if you run these lines of code, you can see at the bottom right that another plot is created. This time the scatter plot points are shown in different colors based on the different species in our data. And you can also see that we have added multiple regression lines. So each of the regression lines corresponds to one of the groups in our data. And as you can see, this time the regression lines are not flat anymore. And this is also reflected by the estimates in our regression model because all of them have been significant. So at this point of the tutorial, you should already know how to manipulate your data, how to visualize your data, and how to analyze your data. However, the R programming language provides much more than you have already seen, and for that reason I want to show you a last section in which I'm discussing some more advanced topics to show you what is possible once you know the R programming language a little bit better. So let's move on to the last section of this tutorial. In this last section of the tutorial, I want to show you some more advanced techniques such as for loops, if-else statements, and user-defined functions. So in the first part of this section, I want to show you how to apply for loops in the R programming language. And for this, we first need to create an empty vector object, as you can see in line 229. So if you run this line of code, you can see that a new vector object is appearing at the top right, which is called vec6. And at this point, this vector is empty. So it's containing only the information that it is numeric. However, it's not containing any values yet. And we need to create this vector in preparation for the for loop that I want to show you in lines 232 to 234. So in these lines of code, I'm applying the for loop function, and I'm specifying within this function that I want to iterate over the values 1, 2, the length of the vector object vec1. So once again, I'm using the vector object that we have created in the beginning of this tutorial in section 1. And then within the for loop, I'm specifying what I want to do in each iteration of the loop. And this is a special thing that you can specify within for loops. So you can specify such a running index, as you can see in line 233. So in our for loop, I'm specifying that I want to create a new output that should be stored in the ith position of the empty vector object vec6. And in this position, we should insert the values in our vector object vec1 at the position I, and I want to add the index I to the values in the vector vec1. So if you run these lines of code, our vector object is updated, and you can see that by comparing the vectors vec1 and vec6. So by running line 236 of the code, you can see once again the values that are stored in the vector object vec1. And then in the vector object vec6, you can see that we have inserted actual values into this vector, because as you remember, the vector was empty at the beginning of this section, and now it contains actual values. And these values are based on the running indicator I. So for instance, the first value in this vector object is based on the first element of the vector object vec1, so the value 1. And then we have added to this the running index I. So at this point, the running index I was equal to 1. So 1 plus 1 is equal to 2. In the second element of the vector object vec6, the running index I was equal to 2, and for that reason this value is one number higher. So in this first example of the last section, I have explained how to run a for loop over the elements of a vector. However, it's also possible to run a for loop over the rows of a data frame, and this is what I want to show you in the next example, starting in line 240. So in this line of code, I'm first duplicating our first input data frame, data1, and I'm creating a new data frame object which is called data12. And then in line 241 of the code, I'm adding a new column to this data frame which is called x4. And at this point, this column should contain NA values. So in the R programming language, NA stands for not available. So in other words, these values are missing at this point. So if you run this line of code, our data frame is updated, and you can see that by printing the data frame to the bottom in the RStudio console by running line 242 of the code. And now you can see that our data frame contains the columns x1, x2, and x3 as our input data frame data1, and a new column x4 which contains only NA values. Now in lines 244 to 246, I'm applying a for loop over the rows of this data frame. And I'm doing that by specifying that I want to run our loop from I in the position 1 to the number of rows of our data set. And then within the for loop, I'm specifying that I want to insert a new value in the ith position of the column x4. And this new value should be based on this formula. So here I'm specifying that I want to use the value in the column x1 at the position I. To this I want to add I times the value that is contained in this row in the column x3. So if you run these lines of code, our data set is updated, as you can see by printing our data set once again to the RStudio console. And now you can see that our column x4 contains actual values. So for instance, the first value is equal to 18, and this is because the value 7 that is contained in the first row plus 1 times the value that is contained in the first row in the third column. 7 plus 11 is equal to 18. And like this, you can also calculate the other values in the other rows of the column x4. So until now, I have only explained how to apply a for loop. However, in the next example, I also want to show you how to specify an if-else condition within a for loop. And we can do that, as you can see in the example starting in line 250. So once again, I'm creating an empty vector at the beginning of the example. And then I'm also printing this empty vector to the RStudio console. So as you can see, this time we have created a character vector which is empty at this point. And then in lines 253 to 259, I'm specifying a for loop. Once again, I'm running this loop from the value 1 to the length of our vector object vector1. And then I'm specifying within this for loop an if condition. And this if condition says if the value at the ith position in the vector object 1 is larger than 3, then insert the character string high at the ith position of the vector object 7. If this is not the case, then specify the value low at the ith position of the vector 7. So if you run these lines of code, our vector object vector7 is updated, And you can see that by printing the vector object to the RStudio console once again. And then you can see that our empty vector that we have created before now contains the character strings low, low, high, low, low, high, corresponding to the values in the vector vec1. So in this example, I have explained how to create a nested if-else condition within a for loop. However, I also want to show you another function which is very similar to that, but which is often much easier to apply. And this is the if-else function that I want to show you in the next example in lines 263 to 267. So in lines 263 to 265, I'm specifying the if-else function, and within this function we need to specify 3 different arguments. So the first argument is the test argument, and this argument should be equal to a logical condition. So in this case, I'm specifying that our logical condition should check whether the values in the vector object vec1 are larger than the value 3. And if this is the case, then the yes argument is assigned. So in this case, once again, we are specifying the character string high. And if this is not the case, then the no argument is used. So in this case, the character string low is assigned. And then we are storing the output of the if-else function in the vector object vec8. So if you run these lines of code, a new vector object is appearing at the top right, which is called vec8. And as you can see by printing this vector to the RStudio console, this vector contains exactly the same values as the vector object vec7 that we have created before. However, this time the code was much simpler because we simply had to apply the if-else function instead of a for loop with an if and an else statement. Another advanced technique that I want to show you is the creation of your own functions. So in this tutorial we have applied many different functions, and as you have seen, there are many different functions available in the R programming language, and you can also import new functions using add-on packages. However, often it's also useful to create your own functions, and this is what I want to show you in the next example, starting in line 269. So in lines 269 to 272, I'm creating a relatively simple function which is called fun1. And within this function, I'm specifying that we need an input value x, and based on this input value x, we are creating an output, and this output should be printed to the RStudio console. So if you run these lines of code, you can see at the top right of RStudio that a new section is appearing which is called functions, and this section now contains a function which is called fun1. So now we can apply this function to our data as we would apply a function that was already loaded by the installation of the R programming language. So as you can see in line 274 of the code, I'm applying our function fun1 to the vector object vec1. So in this function, I'm specifying that the vector object vec1 should be equal to our input of the function, which is called x. So if you run line 274 of the code, you can see that a vector output is created, and the elements in this vector correspond to the values in our vector vec1 and the formula that we have specified within our user-defined function. So in the examples of this last section, I have shown you how to use for loops, if-else statements, and user-defined functions. So now I want to show you a very last example in which I'm combining all these methods in one example. So this last example is starting in line 276 of the code, and in this line of code I'm specifying another function which is called fun2, and this function should take 2 input arguments which are called x and y, and then within this function I'm specifying an if-else condition based on the logical condition that if y is larger than the value 3, then this formula should be applied, and if y is not larger than 3, then this formula should be applied. And then at the end, an output should be returned by the function. So if you run these lines of code, you can see that another function is appearing at the top right in our functions section. And now in the next step, I'm applying this function within a for loop. So in lines 285 to 290 of the code, I'm specifying a for loop which is running from the value 1 to 5. And then within this for loop, I'm specifying, based on the print and paste 0 functions, that a sentence should be returned which contains the text, "This is the result of iteration I," and then the result of the function fun2 should be returned based on the x value 5 and the y value I. So if you run these lines of code, you can see at the bottom in the RStudio console that 5 different outputs are returned, and each of these outputs corresponds to one iteration of our for loop, and each output tells us that this is the result of iteration I, and then it shows the result of each iteration. That's all I wanted to explain in this video. In case you want to learn more on this topic, you may check out my homepage, statisticsglobe.com, because on my homepage I have recently published a tutorial in which I'm explaining the content of this video in some more detail. I will put a link to this tutorial into the description of the video, so you can find it there. If you have liked this video or if you have any questions, let me know in the comments section below. I'll try to respond to all comments as soon as I can. Furthermore, make sure to subscribe to my YouTube channel to get notified about future video releases. I have already published about 500 videos on this channel, and I'm releasing new videos on a daily basis. Thanks a lot for watching. See you in the next video.